calculators out. Calculators out, please. Thank you for being so understanding. Yesterday I had a conference pretty last minute, so I had to go. This is section 6.5, rational root theorem. And yet today is going to be another tool to help us with factoring. Now that we have mastered the synthetic division, we're going to be able to do tonight's homework, which is page 469, numbers 1 through 8. Should not take us too long, so my MUN people and all my people who are super overwhelmed with other things, maybe you could do my homework during snack, and then there way you feel like, you know, I can do MUN all night now. Oh my gosh, I could do chemistry all night if I want now. You ready, Sammy? All right. So the purpose of the rational root theorem is to decide our possible roots. Decide on our possible roots. So far we're recognizing that synthetic division is the homie. Like, pretty much been helping us a lot so far. And helping us find points on any type of polynomial, helping us find what the remainders are. And now look how powerful synthetic division is going to be again. I think I've learned from you guys so far that third period, you guys respond really well to just seeing an example. Okay, so let's just jump into an example. Example 1. Mina, can you see? Yeah. Okay, I can't see you. I should have put Dylan over there. It's okay. All right. Let's say I give you that the polynomial is f of x is equal to 2x to the 5th minus 3x cubed plus 2x minus 4. I'll yell it out, but I want to know how many roots does this polynomial have? How many roots, real or imaginary? How many roots does this polynomial have? 1 hand. 2, 3, 4, 5, 6. 7. Good. 8, 9. Kathleen, what do you think, sweetie? If you had to take a gander, take a guess. What's the same thing as a root? Can you answer that question and then tell me what your answer is? What's the same thing as a root? If I ask you for the roots, what am I also asking you for? What are other words for the word root? I'm sorry? X-intercepts. So x's, right? X-intercepts. Zeros. What's one more? Starts with an S, guys.
Solution.
Solutions. Kanoa, are you with me, sweetie? All right. So Kathleen thinks it's 5. Isaiah, what do you think? Alyssa, what do you think? Also 5. What do you think, Destiny? 5. Tell your group members why you think it's a 5. Talk to each other. Lauren, why does your group think there's 5 roots for this problem? Very good. 5 is the highest power. X to the 5th means x times x times x times x times x. All 5 of those roots are going to give me 5 solutions or 5 zeros or 5 roots. Okay? Do they all have to be real? No. Some of them can be imaginary. Okay? But the idea is I should end up with 5 answers. Which is why today's notes are super intense, because by the end, I need to get all 5 answers out. So here we go. How do we know what the answers are? This is why I need you to take out your graphing calculators, please. Put this in your graphing calculator. Sean, come on. Share with somebody, but don't just sit there. It's okay if you don't have one. You can share with people. That's why you're in groups. Go ahead and put it into the graphing calculator and graph it. You should have this graph right here. Looks like this. And if I were to trace this bad boy, I should be able to get the intercept. Okay. All right, so you know that one of your x-intercepts is about 1.5, just by this graph. Everybody with me?
Yeah.
How many x-intercepts am I supposed to have? 5, but I only have 1 here. What does that mean about the other 4? Don't yell it out. I only see 1 x-intercept right here. If you only see 1 x-intercept and there's supposed to be 5, where are the other 4? What kind are the other 4? Don't yell it out. Destiny? The other 4 are imaginary. Everybody with me? 1 is real, the other 4 are imaginary. Now what we're going to do with this is find all the possible roots so that we can use synthetic division. What happened? Oh, sorry, babe, I don't. So I can use synthetic division to find my roots. All right. Whenever you want to find out what are the possible roots, the only 2 coefficients you need to pay attention to are the lowest and the highest. What I mean by the lowest and the highest is the highest power is x to the 5th. The lowest power is x to the 0. So those are the 2 that you need to pay attention to. The lowest and the highest. Thank you, sweetheart. The lowest coefficient, we call that P. The highest coefficient, we call that Q. And all I have to do, since I know my P is 4 and my Q is 2, all I have to do is write all the factors of 4 divided by all the factors of Q. So the rational root theorem is basically P divided by Q. That's what the rational root theorem is. It allows me to take all of the factors of P, divide them by all the factors of Q, and all those numbers are possible, listen to what I said, possible roots. Not all of them are going to be roots, possible roots. So all we have to do is list them out. Ready? We're going to list out all the factors of 4 and divide them by all the factors of 2. So it's P over Q. Well, what are all the numbers that divide 4? 2, 1, and 4. So we played plus or minus 1, plus or minus 2, and plus or minus 4. The reason why I have to put plus or minus is because 4 divides 4 and negative 4 divides 4. 2 and negative 2 both divide 4. That's why you need both positive and negative. And what are all the numbers that divide Q? What are all the numbers that divide 2? Plus or minus 1 and plus or minus 2. Now when we just graphed this bad boy, you just told me, when we graphed it, we saw that one of the roots was about 1.5. And I'm going to prove it to you how you're going to get this 1.5. Now all I have to do is take this 1, divide it by 1, and then divide it by 2. Well, what is 1 divided by 1? Plus or minus 1. What's 1 divided by 2? What's 1 divided by 2?
Oh, it's 1 and 0.
You guys are scaring me. What's 1 divided by 2? 1/2, plus or minus 1/2. Okay, that's the ones. Now let's do 2 divided by 1 and 2 divided by 2. Let me show you what we're doing now. 2 divided by 1 and then 2 divided by 2. Well, what's 2 divided by 1? Really, guys? 2 divided by 1 is plus or minus 2. And then what's 2 divided by 2? Well, don't we already have that? So we don't need to write that one. Okay. Last one. 4 divided by 1 and then 4 divided by 2. So they're going to get plus or minus 4, and then you already have that plus or minus 2. So I read the graph wrong. This was not 1.5, it's 1.0. It didn't cross at 1.5. And the reason why it's so raggedy is because when you read a graph, there's human error. Okay? So do you guys see how one of the answers is right there? 1? Do you guys see that? All right. So this is how you can find your pool of numbers to use synthetic division. Okay? All right. One of them is real and the other 4 happen to be imaginary. Tonight's homework, you're going to do this. I'm going to ask you, what are all the possible real roots? Not find the real roots, but just what are the possible real roots that you could use from? All right, here's your doyo. Find the possible roots for f of x is equal to 3x cubed minus 2x squared plus 5x plus 12. Whoops. You should have put all the factors of p over all the factors of q, which are, this is your p right here, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. All over. The only thing that divides 3 is 1 and 3. But you can't leave your answer like that tomorrow. Some of you guys are notorious for doing half of the work and then you're like, what? This is the setup. This is not the answer. Kyle, what's your final answer, sweetheart? You missed 1. Which one did you miss? 12 over 3, which is 4. He said that. 1 over 3. Very good. Ready, guys? You should have plus or minus 1, plus or minus 1/3, plus or minus 2, plus or minus 2/3, plus or minus 3, plus or minus 4, plus or minus 4/3, plus or minus 6, and plus and minus 12. This is your answer. Finding all the possible roots. These are all the possible ones. Yes, this is the possible roots right here. Not this, this. Don't yell it out, but what did we just find? What did I just say? What did I yell at? What What did we just find as far as the graph is concerned? Jarrell? All of them? How many roots does this bad boy have? 3. And these all, that's 3 of them? You're on the right track, babe. No, come on, I believe in you. You got it. So there's 3 roots, right? What did we just find? So are these all the roots? All of them are roots? What did we just find? There you go. The 3 roots could possibly be in here.
So there's a chance that it's not.
All the real roots are one of these. That's it. The imaginary, that's another discussion. But if you want a real root, absolutely it's one of these. No questions asked. So when you do synthetic division, let's say I want you to find a root here. How do you know if something is a root when you use synthetic division, Gerson? What do you know about the remainder? If I want it to be a root, what is the remainder? 0, right? So if I want to use synthetic division and see which one is my root, do you think I'm just going to make up numbers? No, now I have a pool of numbers to try on synthetic division. Because I'm not going to just be like, I wonder if 1 is a root. I wonder if 2 is a root. Are you really going to go through every number in the world? Seriously? No, right? Now you have a pool of numbers that you can test for synthetic division to see which one is the root.